My name is Marcus Brown. With me I have Philip Morrow, and we're going to show you a really quick run through of just about everything we think is worth mentioning in what's new in SOLIDWORKS 2018. So the first thing I want to tell you about is something that doesn't seem kind of impressive at first, but it's the ability to log in to the SOLIDWORKS website and SOLIDWORKS My.SOLIDWORKS portal from inside SOLIDWORKS, from inside the interface. Now, again, it may not seem like it's all that big of a deal right at first, but there's several things that it does. Obviously, if you go to the customer portal or to MySolidWorks.com, there's a lot of learning resources that are available. But there's a new feature with that incorporated login where you can synchronize your device settings. Think of it like a copy settings wizard in the cloud. So no matter where you go, if you log into MySolidWorks.com on your SOLIDWORKS login or on the SOLIDWORKS interface, you can pull your settings down anywhere you are. If you go to the MySolidWorks.com, there's now an admin portal. It just went live a couple days ago. This will allow you to see all of the licenses and all of the users that are associated with your company. In addition to being able to see what you have, what expiration dates, what computers are all activated, you can actually convert some of your standalone licenses to something called online licensing. Now, this is perfect for those of you that use home use license or you have multiple computers that you use and you don't have a floating license. Using online licensing is like a kind of a personal license that is attached to your login. So when you log in to that MySolidWorks login in the interface for SOLIDWORKS, the license just starts. No activation, no deactivation, no worried about whether or not you deactivated it before you lost the computer or got rid of it or changed computers. So it's very easy to work with. It does also have an offline mode. So if you're going to be away from internet access for more than up to about 30 days, you can just go offline and take that license with you wherever you go. So I want to take you fully into SOLIDWORKS and show you just a little bit about what SOLIDWORKS 2018 has to offer. The first thing you'll notice is this welcome screen. And again, it's one of those things that I didn't really think would be that big of a deal, but the more I use SOLIDWORKS 2018, the more I really like this thing. It has your new files, so you don't have to even click the new button. There's your new part, assembly, drawing template. Here's your recent documents, folders for recent documents, and various resources, such as the customer portal or the forums. There's a more advanced full recent documents list. There's also some learning information like tutorials and sample parts, and even some alerts showing you when things are available. So for example, Service Pack 5 Early Visibility of 2017 is available. Very easy to find. So I'm going to open up a file that I've been working on recently. Normally I would open this up ahead of time, that way you don't have to sit there and watch this thing open, because watching files progress bars is kind of like watching white people dance, and that's in Philip's presentation. That's where that's going to be in this presentation. But what it does is it gives us this nice status bar. And if you take a look here, it's showing me what the major components are that are being opened, kind of listing them off as I go. It shows me how many I have and how many I need to, how many total, how much time has passed, and how long it took the last time this file was opened. The last time this file was opened, it took less than a minute, just under a minute. Now, it may feel like 10 minutes, but at least now I can kind of understand what exactly is going on and which steps of the process are taking a long time if I have a large assembly. Also, it helps you to plan out your coffee run. If you know it's going to be 58 seconds and your coffee machine is 36 seconds away, which I'm sure you've checked that, right, and measured it, you know that you'll have time to go get that coffee. You should expect to see some pretty nice improvements in your assembly open time in 2018. But if you're having problems with it, you can further evaluate it using the performance evaluation. Now, this has always kind of been there. This is like the rebuild statistics, but it's gotten much more powerful. Any of the most common and most likely cases of problems that are going to cause your large assembly to be slow to work with or slow to open are all going to be graphed here. So the open time, any files that haven't been up converted to the latest version, any files that are really complex in terms of graphics, detail, or just the image quality slider being really high. We've found this in many cases to be the most common cause, and you'll see one or two or a handful of really bad eggs causing the entire assembly to get really slow. If you want to continue to dig deeper, you can go into assembly visualization. Now, assembly visualization has been there for years, and it allows you to graph various details like mass or cost on your model, and not only with kind of a bill of materials style interface over here in the table, but also with colors out on the model. What's new though is this new performance analysis button. And this gives you the opportunity to add automatically things like total graphics triangles, open time, rebuild time, so you can see which files are causing you the most pain so that you can address those files. If it's a file you knew was going to be big, then you can kind of live with it, but other files, you know, like this guy right here, this is really graphically intense, probably because it has some internal detail. Well, I'm just trying to show that there is a plug here, so I'm going to go to a low detail version, just a simplified version that doesn't have all that internal electrical detail on the plugs, which gives me a much faster, more responsive assembly and gives me the information I need to act and improve this assembly. So for those of you with large assemblies, 2018 has some fantastic tools to really speed things up. If you're trying to take a look at your model and interrogate the model graphically, you may use a lot of transparency or hide parts. You can now do a top-level transparency, just to apply transparency to the top-level assembly, and everything becomes transparent all at once. My favorite thing about this is not only is it fast and easy to make it transparent, it's also fast and easy to turn transparency off, so that when you have a bunch of floating transparent components all over the place, it's really easy to get around and fix those up. If you have some parts inside of folders like I have here, you can see that all these folders keep everything really well organized, but sometimes it's hidden or it's not clear because they're in folders what the status of each of those are. So if I hide a part, how do I know at the top level assembly that I've got hidden parts in here? That means I need to show them before I go to drawings or start making my bills of materials. Well, I hid a part inside a folder, and now the folder gets a clear stripe. If I suppress a part, that folder then gets a gray stripe. And if there's a hidden and suppressed, you'll see a stripe of each color in that folder. It makes it really easy at a glance to understand the status of all the components. Even though you have a really nice organization system, you'll be able to quickly understand the status of all your components. I need to grab a couple components here on this panel. And to grab it and make sure I grab the whole thing, I'd like to box select. But when you box select over a panel, it doesn't allow you to do the box select. It tries to drag your panel. So SOLIDWORKS has added a new keyboard shortcut, the T key. When you hit the T key, it allows you to box select over geometry. And if you do Control T, you can then select multiple things or continue selecting things very quick and easy. So the T key is going to be a big help for anyone trying to make box select of a small component in the context of a much larger assembly. I need to open up and finish up this cup tree design. So to open it up at the subassembly level, I'll use my D key. The D key introduced last year brings your breadcrumbs to your cursor. So you can take a look at that critical path to the top level assembly and then act on any level without having to go and traverse the feature tree. For this design, I need to add a couple more arms and cups. And I'm going to go ahead and pick for my vertical axis the cylindrical face, grab my components to pattern, and tell it how many I want. Now here's the problem. I want it to rotate as I go. And so there's a new feature in 2018 that allows me to choose a central axis and then specify a rotation. Every instance from that point forward gets rotated by that increment. So if I say I want 1/3 of a full turn, it's going to give me just exactly what I'm looking for in a nice spaced out arrangement of these cup arms. So it's a really cool improvement. They're continuously making these pattern features, both in component assemblies and in parts, much faster and easier to work with. Open up another subassembly and show you another common thing I come across. I want to add a mate to the bottom of this burner. But when I rotate the view to look at the bottom, you'll see that I can't see it. It's down inside this tray, inside this box. I can't get to the back face. So I find myself using select other a lot when I'm in the mate command. So SOLIDWORKS has introduced another new keyboard shortcut, the Alt key. Hit the Alt key while you're hovering over a face in the mate command, and it immediately does a select other. hiding the face that's in front of you so that you can get to the face behind it. Very quick and easy, without a lot of extra right-clicking or left-clicking. I can get that thing mated into place. I'll complete the process of adding mates to this design with a couple concentric mates. Now, after I add the first concentric mate to this whole pattern, I realize this tray and this burner really weren't quite made to work together. They will work together, they'll fit, but if I try to make a second concentric mate, in 2017, I might have gotten a message that says, "No, this is overdefined," or you need to choose a different mating strategy. In 2018, it gives me an automatic parallel mate relation. If I want, I can even force it to be concentric and gives the new misaligned mate feature. So that parallel or the misaligned mate is a new capability for pairs of concentric holes. If you do misaligned mates, you get to choose which of the two mates is going to be aligned, and the other one is simply used for orientation. You can also do a symmetric alignment, which means that it's going to split the difference between the both of them, giving you the most realistic example. It shows you how much deviation is there. And if you want, you can actually come in and specify a maximum deviation possible, meaning that if it goes beyond that value, you'll get a rebuild error. If you want, you can turn off the capability to do a misaligned mate in the system options. That way, if you've got people that really should be just going back and modifying the original design, that they'll be forced to do that. This is great when you have a bunch of imported models, such as these burners. I'm not manufacturing a burner, I'm just integrating them into my design. I'd like to keep all the original manufacturer information intact, and misaligned mates allows me to do exactly that. One more quick thing that I want to show you in assemblies, which is really useful, is the ability to work in an exploded view and add smart explode lines. So I've already created my explode view, and now under the explode view command is this insert and edit smart explode lines. Now watch what it does. It grabs every part that was involved in an explode and immediately throws a parametric line from its origin to its destination. Now it may not grab the right location. So on these bolts, it did a nice job of kind of picking dead center, but you can specify or drag it to a new location point so that that line makes a little bit more sense. And when you say apply to all component instances, suddenly every bolt that has an explode line is attached in the same way as that original one. Now, not only does this quickly add a lot of explode lines, it also makes it possible for you to keep those attached as changes are made. So if I come in here and I start manipulating the explode line or explode scenario, it's going to very quickly and easily update and make sure everything looks right for my explode view. So you may find yourself working in SOLIDWORKS 2018, and who knows where you are. Maybe you're on vacation, maybe you're on a business trip at a customer site, maybe you're walking around town and you just need to get a little bit of work done. Wherever you are, if you don't have room for a mouse, or if you don't even have a mouse because you're working on a remote tablet or remote desktop, SOLIDWORKS 2018 has some new capabilities for you to use your touchscreen without a keyboard. Now, the environment is called Touch Mode. It's in the View menu, and it shows up as a series of icons on the left side of the screen. Now, if you've ever tried to do real serious work using just your touchscreen, these are the buttons that you found yourself needing. So zoom, pan, rotate, those are all really easy to use with the touchscreen, but when you need to move a component, interact with it, the lock rotation button makes it possible for you to quickly lock the rotation and then drag either a box select or move a component, whatever you want to do. To execute a quick command, the shortcut menu is another soft key. Just hit the shortcut menu and all the icons for your shortcut menu come up. The icons are going to be spaced out a little bit more than normal. That way it's easier to pick when you're using your touchscreen. If you like mouse gestures are done with the right mouse button. Touch Mode has mouse gestures as well. Just hold your finger down for about a second and then swipe. When you swipe, it'll swipe through the command and execute it quickly and easily. If you need to get to the right click menu, don't worry, just click it to get the context menu. The right click menu is a fly out away, just kind of flies out below it. So all of the workflows that you're used to, context menu, shortcut menu, mouse gestures, etc., are very easy and intuitive. If you're trying to make a very precise selection, hold your finger on the screen or your stylus on the screen, and it will create this magnifying glass. You can zoom in and out and make any changes you need. If you need to type in a numerical value, there's a number pad that pops up. I mean, they've thought of everything. So wherever you're at, whenever you think, oh man, I need a keyboard, they immediately make available to you everything necessary to keep moving. Now, sketch mode is one of those rare opportunities where it might actually be preferred to use a touchscreen. You can turn on this new Sketch Ink toolbar and turn on your pen and start drawing anything you want, just doodling on the page. Now, in addition to that, if you turn on auto shape, it'll convert those lines and arcs, or those sketches, freehand sketches, into sketch lines and sketch arcs. If you turn on auto sketch entities, they become actual sketch entities. You can convert ink to sketch or vice versa, and then from there, it's just a normal sketch. Anything and everything you might want to do is now available and intuitive. So for example, in this, I'm going to use some sketch fillets. So I'll lock rotation so I can do a box select and grab everything quickly and easily. Same thing with the mirror. I unlock rotation to zoom out and then lock rotation to do a box select and execute the command. These sketch relations are automatically being added. So if I draw a circle, for example, and then I draw another one inside of it, it automatically makes them concentric. Drag that point to another point, it snaps. If you want to add or select multiple entities to perform a command, the new multi-select button on the side acts just like holding down the control key. Very quick and easy to work with inside 2018, no matter where you are or what device you're on. So let's talk a little bit about managing all this data that we're going to end up with in SOLIDWORKS. We don't have Workgroup PDM any longer. Workgroup PDM, the infrastructure, the architecture of it simply was not scalable. It was an antique group of software. So they replaced it a couple years ago with PDM Standard. Anyone who has SOLIDWORKS Professional or Premium and who had Workgroup PDM is now entitled to use PDM Standard. We have a lot of great quick start and migration options available. So if you've never implemented PDM, or if you're using Workgroup PDM, it's probably time to give us a call and talk about this. So let's take a look a little bit about what is new inside SOLIDWORKS PDM 2018. When you get into the vault with PDM and you start working on a design, let's say we have a problem with one particular design. I want to take that design, I want to take that part and try to solve the problem, but I'm not really sure exactly how I'm going to solve it. I've got several people with different ideas on how to do it. Well, you can use this new branch and merge functionality. Branch and merge makes a copy, several different copies of that same part so that you can quickly work with each one of those designs in a separate design path. Once you get to the point where you're like, okay, well, this is the design I want, you can merge that part back into the original assembly structure. So here you can see we went through and found the best design for the foam cushion on this seat, and we were able to merge that back in the design, and it's as if we knew what the answer was going to be before we got there. Another big enhancement inside SOLIDWORKS PDM is the integration of revision tables. So revision tables have always been there, but now we have full, complete integration between those tables and PDM. So if I add a new revision on a drawing that's controlled in the vault, by default it shows up as an asterisk. And when I check that file in, the data card is clearly going to show that there's no actual revision yet released on this design because it's in process and has not been approved. Simply submitting for approval or approving that component will very quickly and automatically up the revision level, both on the data card and on the drawing. So your title block, your balloons, and your revision table are all going to be synchronized and ready to go at the same time. If you see PDM is a really powerful tool, but you have more capabilities that you need, let's say that, for example, you need to keep track of customized bills of materials, you need more parallel workflows, you need to worry about timelines and project management. We're introducing a brand new product called SOLIDWORKS Manage. Now, you should expect to see more information coming up in the next month or two because this product is brand new. The way it works is it sits on top of PDM. So any files you put inside the vault will automatically be available to be promoted into SOLIDWORKS Manage. Once it gets into SOLIDWORKS Manage, you can break that information out into much more complicated processes and procedures. So for example, here's a file, and in that file, I have various projects that need to be performed in order to finish the design out. I'll use a project template, specify various resources and tasks that need to be done in order to complete that project. And then as people get those tasks assigned, they can specify how far along they are. And that updates my Gantt chart, which updates my project completion percentage. Each one of these projects and processes has a full workflow that can be implemented. And these workflows can actually be done in parallel. So for instance, I can start performing an ECN while I'm also doing a prototype or a sample drawing. Everything that you put inside Manage, everything that's managed, can then be graphed on these customizable dashboards. So you can see progress of various projects. You can understand what files are in process, what the workload levels is for each of your employees. So for anybody that is having trouble getting more out of PDM, and you're considering a move to a PLM or an ERP system in order to try to manage the additional information, SOLIDWORKS Manage is made for you. We don't want to have to use too many different tools and logins. We want everything in one fully connected and integrated tool. So jumping back into my design, actual design work, I want to add a component here. And I found it on Amazon, and I found a 3D model of it on GrabCAD. But the problem is it's not native SOLIDWORKS. It's an STL file or a step file or a Pro-E file. Well, 3D Interconnect gives you the ability to open any file type pretty much and pull that in, whether it's native to another CAD package or it's a neutral file like a step file. And the way 3D Interconnect helps you is by eliminating the need to create a separate file, a copy of the original. If you see in my feature tree, this file, which is the .stp file extension, shows up in my feature tree directly. There's no copy, so I don't have to worry about making sure that the step file and the SOLIDWORKS file kind of have the same name or sit in the same location. In addition, as I add these mates, it's very quickly going to be able to position this part in place and be ready to go. Now, if this was a native, let's say Inventor, Pro-E, or CATIA file, then it would very easily be able to be updated in its native package, and then those mates would be reattached on the other side. But because this is a neutral step file, it's not going to be able to reattach mates, but it does not require that conversion process. 3D Interconnect also has new expanded capabilities for bringing in additional design data. Let's say I've got a part here that must have a panel mount sketch. That panel sketch can be embedded in the 3D model. So I'll start a sketch on my panel, and then I'll go to this 3D sketch that was brought in from the supplier and simply convert that onto the panel. Meaning, when I delete out all my buttons or anything else I don't want in the panel cutout, I get exactly the dimensions specified by the manufacturer, and I can make this cut through the panel. I'll hide the part so you can see what that panel cut looks like, but this means I don't have to go to a separate data sheet in order to understand and figure out what the designed panel cutout is. I can just pull it directly off the model. Another example that you might get from a model is some custom properties. Let's say this file is coming from another CAD package, and these files, these PAR files, PRT files, they have custom properties in their native programs. No problem. This thing is going to bring in those custom properties directly from those non-native files, reusing that data and eliminating the extra steps to try to recreate what was done in another program. So no matter what program your customers, your suppliers, and all the vendors are that are creating these files online, you'll be able to use those files quickly and easily. But let's take this a step further, because there's some file types that are becoming more prevalent that really don't even come in at all in many cases. I'm talking about things like step files or STL files, 3MS files, parts that are basically mesh models, maybe scanned or maybe exported from a simulation result. this mesh geometry, it may look like it's CAD geometry, but it's really just this mesh item. There's nothing you can grab about it. There's nothing, parametric about it. It's actually really hard to work with. But in 2018, we have some new capabilities for working directly with these mesh models. We can do sectioning of the mesh. If the mesh is watertight, we can start taking a look at things like mass properties or volume. If we want to apply a material, we can apply a material to this mesh and it'll actually apply real view appearances to it. So it looks very realistic. But that's not all. In the past, we would use scan to 3D to try to reverse engineer the part and try to create a solid from this mesh. Well, 2018 has a new command that's available in every seat of SOLIDWORKS called Surface from Mesh. The way Surface from Mesh works is you'd say, I want to kind of reverse engineer a single surface. I want to create a surface body. I'll use my paintbrush to grab a few facets of this mesh and then calculate. And what SOLIDWORKS does is it says, well, this is all part of one big planar surface. I'll go ahead and reverse engineer that surface, and I now have a single surface body that represents that back face, meaning I can now create sketch entities on it or do anything else that I want to do with it. I can also grab like this cylinder, and by clicking OK, I now have a cylinder body or a cylinder surface body that I can work with. I'll hide that main mesh body so you can see what I've created, but this is actual real geometry. This is not mesh data. This is a solid body that's planar and cylindrical and allows me to start doing surface modeling or just simply keep moving forward and kind of use those as reference. Now with this graphics body, if I want to take it one step further, I can go ahead and convert this to a mesh body. A mesh body is kind of a hybrid, like a vampire that walks during the day. And what it allows me to do is create a solid object that's watertight that can be edited, but it's not a pure solid model. It's actually that hybrid solid mesh. So I can start doing additional actions to this. So for example, let's say I want to add some geometry to cut out the bore. This is supposed to be a clamp, and I want to cut out the opening for the pipe that it's going to connect to. It is possible to create sketch relations to these facets, to this geometry, and actually locate new features and new dimensions based off the existing design. So even though it's a mesh model, and it's very difficult to work with or grab anything, it's now possible for you to kind of pull data off of it to create surface bodies or to create full parts. In this example, I'm going to extrude the area that I want inside here, this part and this part. Now, I can't just directly cut a mesh body. When you may have a mesh body, there's only one thing that you can really do with it, and that is to kind of do a Boolean operation with another similar type body. So even though this is a solid, I can convert this solid to that hybrid, that same hybrid mesh result, which means I now have two hybrid mesh bodies, and I can create a combine operation to subtract one from the other. We'll put these in the other order here. There's my main body. I'm going to cut away this new one, and it's going to create that shape. Now here's the thing, this STL file that was previously almost unusable now has a real geometry face on the back so that I can add mates. It has modified geometry so that I can work with it. I can add custom properties. I can add mass properties. And when I go to insert this into my assembly, look how easy it is to work with, because it is full real geometry, although it's also this kind of weird mesh body. So I add my profile center mate, and this is as good as it gets. It's everything I need of a part file, even though it came from an STL file, 3MF file, scan data, you name it. It's very easy to work with. So that's a really powerful new function in SOLIDWORKS 2018 for working with mesh data. Here's another brand new feature. It's in all packages. It's called the tab and slot feature. I've already got a few tab and slot features assigned to this part. And if you take a look, The tabs line up with the slots. They're almost exactly the same size except for some assembly tolerance. And it makes it possible for me to assemble this, weld it up, and make sure that everything is located correctly without having to worry about complicated templates or fixtures. To create a new tab and slot is very simple. Just grab an edge where you want your tabs to go and tell it how long those tabs need to be, which also defines where the slots are going to get cut. Simply specify your size, so you have a very similar, very intuitive and familiar user interface over here for specifying the information. You can say how long you want those to be, how much gap you want, whether you want a chamfer or a fillet on those edges. It's all going to be very easy to manufacture, and it both cuts and adds tabs for that tab and slot feature all in one step. Now, this is possible to work with in both an assembly and a multi-body part, or even a single body part. There's no limitations on what you can do with this tab and slot feature. I've got a part here that needs to be manufactured. It's actually going to be kind of a support bar for a spare tire. And it's going to be a sweep in 3D, and I've started my 3D sketch, but if you notice, my arc kind of flipped out on me. I made a change, and the sketch kind of flipped, and now I'm left with kind of this problem. Well, with 2018, just reverse that endpoint tangency, and it's going to create a really nice look on that arc, meaning I don't have to go through and redraw that. And if anything changes again that's really severe, like say I mistype it and type in a number that's extraordinarily too large or too small, and the whole sketch blows up, when I bring it back, if something flips, I can flip it back with no problems. I can even do a mirror entities inside of 3D sketches, which means that you use a plane rather than a center line because you're in a 3D sketch. That mirror entities works exactly like you would expect it to, in the same way it works in a 2D sketch, and all planes are now available and accessible for you to use for creating sketch relations. So I was able to finish this design out quickly without having to do a lot of redesign, which might potentially cause downstream mate problems. I'm getting the electrical or the mechanical design pretty well finished up. It's time to start considering some of the electrical designs. Now, when you're working in an electrical schematic, a lot of times there's very specific requirements for formatting that need to be incorporated. So for example, they may say, I want every tag in the entire drawing to always be red. So you can go into each of your symbols, change the attributes so that the tag attribute always shows up red. The problem is you've got a whole bunch of symbols you got to use. So there's new project level attributes that can be set inside SOLIDWORKS Electrical. With these project level attributes, you simply say that all tags need to be red, and no matter what they were in their design, they show up red. This also is great if you have a lot of different customers and you need to quickly switch back and forth between different standards. Now I've got a title block here that I need to modify to add a multi-level terminal to one of these blocks. It's very easy now to simply define multiple levels in the terminal. It will set up the numbering scheme very clearly inside the template. And then when it creates the drawings, it also is going to very clearly differentiate where the wires go in the multi-level terminal. So take a look at this. This is a drawing that's output automatically by the system. I didn't draw this. I don't have to draw this. It's automatically created. If you have a large library that you want to customize of all your manufacturer components, like let's say you've got 38999 connectors that you have a lot of different variations on, and you want to separate the jacks and the plugs, it's simple to create custom categories and subcategories to keep the organization of your material or manufacturer library clean and easy to work with. If you've got this design all done, right, I've got all my components, all my wires ready to go. I'm ready to go route my harnesses in 3D so that I can show exactly where everything goes and start figuring out my nail board drawings. SOLIDWORKS Electrical 3D is much faster and gives you a spline-based routing of harnesses. So that spline-based routing is going to give you a more realistic image. It's going to look like an actual wire would look with accurate bend radiuses, minimum bend radiuses, and shapes and sizes. So SOLIDWORKS PCB is also a new product that's come out in the last year. You may have seen this last year, but we've got quite a few new enhancements this year. With the SOLIDWORKS PCB, it's a program that's built on top of Altium. So it's a proven technology for building circuit board schematics and board layouts. Now, with PCB, it's possible for you to quickly work with the user interface just like you do in SOLIDWORKS. So we've got this nice ribbon style interface at the top, and depending on where you are, instead of a part assembly or drawing, we're talking about circuit, packaged layouts, symbols, schematics, or the board design. The commands are all going to update automatically. If you make a change or you're trying to execute a command and you need some additional commands, the tilde key allows you to get more advanced capabilities or more advanced commands out of that function very quickly without having to go to a menu system. If you want to bring in a component like a capacitor, the supplier links allows you to quickly go through and browse the categories of pretty much every major circuit supplier. You can search by keyword or by various parameter searches. Once you find the design you want, you'll be able to see its availability, cost. You can even pull the data sheet directly from that design. The suppliers can be turned on and off. So if you have preferred suppliers, you can very quickly say, I always want to buy from these people if it's available, so that your searches will give you the most appropriate parts. With the DB links, you can access additional information from your various other databases. So let's say, for example, you have an ERP system that has all the part numbers or all the bills of materials for your designs, and you want to work with that. You can link up your database from a PCB and from this other program to share that data quickly and easily. If you have footprints that you want to create, you can now create footprints using this nice symbol wizard. It very quickly creates the symbol and allows you to map all the various different pins and components. If you get everything lined up and you want to start routing your board, you can do things like differential pair routing. Simply adding net labels to your various schematic components makes it easy for you to then route these differential pairs quickly in the board design. And it automatically routes around, through, and even under various other routes. You can use multiple routing, where it's going to just allow you to grab the shift key and select multiple pins to quickly route a whole series of circuits from one place to another. If you need to do a footprint, there's a new IFC footprint wizard, or IPC footprint wizard that allows you to grab the footprint or design a particular footprint according to that standard. So no matter how complicated you need it to be, it's very easy to work with. And when you add a component, whether it's a new IPC component or just a new design, it's possible for you to import a 3D body along with that component. Now that could be a step file, a SOLIDWORKS CAD file, Parasolid, you name it. And that gives you the ability to view both 2D and 3D views of your board layout. So for instance, this board layout, I can just quickly hit a button and it goes from 2D to 3D at the click. Now, once you get to 3D, it's not just for visual looks. It's not just because it looks cool. You can actually get inside the traces, inside the multiple layers, to take a look and make sure that your copper is not overlapping, make sure your via placement is correct, and very quickly confirm that this design is going to be functional and robust. I'll push this information out to SOLIDWORKS, which means that all the data, including the board layout, the component placement, and all the information is available for them to use inside SOLIDWORKS. Now, in this case, I didn't know what board size needed to be, so I made it a big rectangle. But when I pushed it to SOLIDWORKS, they were able to rebuild the outline of the board, add mounting holes, and kind of customize everything else. Now, they can push and pull that data back and forth. It's very much like a negotiation. So for example, let's say that I like the idea of the board outline, but the holes don't match up or need to be moved. I can reject certain features and very quickly get to the point where we have a design that works in both environments and it's automatically pushed and pulled back and forth. That's the end of my session. Philip, you ready to go?
Oh yeah, I'm here. Let me see if I can change the presenter to myself and show my screen. Which screen are you seeing right now, Marcus?
I see you. Are you eating barbecue or what are you doing there? Drinking beer?
I am on a mountaintop in Switzerland in that picture, drinking beer.
Very nice.
It's pretty amazing. It's a pretty amazing place to be. So that's the one I included, although I really just put a picture of myself so that those of you out there who recognize my voice right now can see me, because I bet a lot of you here have heard me on the phone or have seen my YouTube videos, something like that. This is what I look like. I'm an AE here in Austin, Texas. I do a lot of simulation work, but really I'd like to pick up right now where Marcus kind of left off. He showed us some great ways to do design work and to manage those designs. I'd like to pick up on some ways to document and share these designs with others, starting with SOLIDWORKS Composer. Now, SOLIDWORKS Composer allows you to start the technical documentation process as soon as you've saved your first part or assembly. So you might be working on a high resolution image, an animation, some interactive web content. If your design changes in SOLIDWORKS, there's no need to go rework all those technical documents, just update them. This thing does your work for you. And if you are building some animations, maybe you took some of the time to make a nice exploded view, you can reverse all of this in one click, or just take the keyframes you want. You can include scaling, flashing effects, and get a nice collapse with one button. I always tell people there's probably a way to do something once if you find yourself doing something twice. For instance, if you've done something over in SOLIDWORKS, like created a bill of materials on an assembly or a multi-body part, just automatically import that into Composer. Not only does that mean it's fast, you don't have to do any rework, but it makes sure all your info is up to date in case you're doing something like making a sales bid package. And once your numbers are straight, you're going to want to make sure you have a consistent look and feel. So just import your display states, appearances, colors, and textures to Composer so you don't end up with something that has subtly different colors in it. Now, if you have worked with Composer out there, you probably know it's super fast when you have really big assemblies. And it can do this, lets you fly around and cross-section really fast because it just uses display data. You can get this same level of performance over in SOLIDWORKS anytime you use Large Design Review to open an assembly, or use speed packs like I've done here. And what I'm happy to say in 2018 is if you're using speed packs, you can set these to automatically update on a rebuild or save, so you never have to trade off between intelligence and performance. Now, I'm trying to make a big layout to show somebody what I would think of a shop floor. You know, how should this look? And I've got multiple levels here. What I'm using is magnetic mates. Magnetic mates support multiple ground planes, so I'm just going to activate this mezzanine ground plane. And when I insert a component that has some published magnetic mate assets, notice I just drag it in and it orients itself to that floor. I even just put it near another magnetic mate point, drop it like it's hot. That's one click and it orients and snaps up. There's even this little lock button right next to my finger, so I can lock that mate so when I'm dragging around more components, it doesn't accidentally come unsnapped. That means I'm only adding one mate too, even better for an assembly. Now, if you haven't done this before, there's only a couple things you need to know. The tab key will rotate your components, and the open and close brackets are going to cycle through the available mate points on either component. So this is like playing Roller Coaster Tycoon or just snapping Legos together. It only takes me a couple seconds, and I could say, hey, how about we set up this whole shop floor, this conveyor system like this? And I do want to show people designs and share them with them, but you know, whatever I'm making, whether it's a conveyor system or an RV, I better make sure the thing actually works before I show it to somebody else. And that's where simulation comes into play. And I am a simulation guy, like I mentioned, so when I look at something like this large RV, I think about important analysis questions, like, am I going to be able to watch satellite TV while driving around? We got Game 7 coming up. I don't want to miss it. So I started looking at some of the components that attach this antenna to the RV. SOLIDWORKS 2017 actually brought us some really cool sim tools, like the ability to do stress hotspot diagnostics. SOLIDWORKS will show me here in gray just automatically where it might make sense to further refine my mesh or add more triangles here to get good stress results. Well, 2018 expands upon this in the same interface here with stress singularity diagnostics to show me not only where I need maybe more elements to get better stress results, but where it might make sense to make a geometry change, such as adding a small fillet to an internal corner. But the truth of the matter is, I want to look at the whole antenna. I don't just want to look at the parts that bolt it. We got a lot of stuff going on in this whole assembly. And I've done some setup, but I've also worked on those individual parts. If I do something twice, I should probably find another way. So I'm just going to import these study features. Even though those were done in a completely different file, I can choose which features I want to import to this assembly. I'm going to take just the fixtures. Notice I don't have any fixtures here in my assembly simulation, but in this mounting plate I did. And when I hit import, they show up that quick. In fact, putting this whole assembly together in simulation is easier than it ever was before. You ever work with a pin connector? I'm going to make a pin connector here. It goes through a lot of different components. I'm actually picking a face on a shell, a face on a solid, an edge off of a shell, several bodies that go together. In 2018, I can put a pin through up to 10 different selections. So I don't have to make multiple pins. It's just like this is in the real world. And I'm just about ready to run this simulation, but the truth of the matter is it's a dynamic situation. I'm driving around, I got wind loading, so I'm just going to copy the study. And while I do that, I'll turn it into a linear dynamic study. Super nice to do that because now my study's done, right? No rework. All I have to do is hit run, and I'm good to go. But there is a downside to going to dynamics or nonlinear stuff, and that's that it takes a long time to solve. You want more info? You got to wait a little longer. So I'm going to jump into the properties and just set up a notification to email me when this thing is finished. Not going to walk away from my desk, go see a movie, come back. I know that this thing will have been solving. I get a little email on my phone. When I come back, I'm not waiting on any messages. I know my sim is done. And you can wrestle with should you technically bill for this time or not. That looks pretty good, but this was a finished product. And I really think the best application of simulation is in the design cycle by engineers when you're coming up with designs, which is why I want to show you my favorite addition to SOLIDWORKS 2018. And that's parametric optimizations here. This is topology studies. Sorry, it's a non-parametric optimization of geometry. So what does that mean? Well, these topology studies are available in all Simulation Professional and Simulation Premium license types, and they look a lot like a regular simulation. Here I've got a tree with supports and different loads on it, but I've got a new goals and constraints section. What you're looking at is the arm mechanism that opens up the actual hood on this RV. And I've over-designed it for sure. I'm going to optimize this for a best stiffness to weight ratio, and I'm going to try and cut out maybe 70% of the weight and be aggressive. I've got some manufacturing controls as well, so I've added some preserved regions so SOLIDWORKS won't remove material where I need it, like for a bushing or some hardware. I won't have to worry about bolt tear out. And I can also add symmetry planes, thickness controls. I'm going to add a demold direction and just tell it to do kind of stamping with a pull direction. I know by doing this, I'm going to get something that's really easy to machine. This does use an iterative solver, so I'm not going to make you wait for this thing to crank out, but the type of results you get from this are first, the stress results that you'd expect to get pretty much from any simulation, but second, a material mass plot. That's going to show me the mass that plays the biggest part in sharing this loading. You can see here it's a mesh example of it. And this is the material I absolutely can't remove. Now I can move a slider and add some more mass material back, but what I'm going to do is calculate a smooth mesh because this is all chunky, it's all blocky, it's hard to use. When I calculate a smooth mesh with this one button, I can immediately save that as a new configuration or a new part. So you got something like a Markforged printer sitting around, you could print this right out and go plug it into your design. But personally, that's not the method I'm going to use very much. I do like things to be parametric. I want to lock them down with dimensions. So I'm going to go back to my model environment, and I'm going to make use of SOLIDWORKS simulation display technology. It's available for all study types. I'll just use it for my topology, and I'll show my material mass plot on top of the part in the regular CAD environment. That's super nice for photo rendering, but it's also like having a 3D sketch that I can work with and draw my own dimensions on top of. So I actually worked with this one a little bit to see where I'd get to. I didn't cut out 70% of the weight, but I cut out a lot. And I know the design I ended up with is something that's optimized for best stiffness to weight. This type of technology can really give you natural, ergonomic, and organic looking shapes. Really something I've been excited about for a year or two now, and I'm glad to see it in 2018. You know, a lot of these parts that I did analysis on, since they're on an RV, I wanted to do some fluid drag. I wanted to see drag forces on my antenna, and that's where flow simulation comes into play. And also my second favorite enhancement to 2018, the addition of free surface flow. This calculates the interface between two immiscible fluids, such as water filling up an empty tank just filled with air. Or how about oil and water mixing and settling? You can do two liquids together like this, a gas and a liquid. You could do a gas and a non-Newtonian liquid together. Really quite a powerful analysis to do, and it is transient. Now, if you want to save some time, not run a transient study, there's no better way than making use of symmetry in your model. If you have something with cyclic symmetry, you don't have to cut that down to just a half or a quarter. You can use axisymmetric or axial periodicity, as we call it, to cut this down to the smallest slice to make sense for your geometry. That works with rotating components. It works with heat conduction in solids. There's really no limitations to it. And I can just analyze a very small fraction of this design to know how my overall impeller is going to work. Finally, a new fast Fourier transformation plot looks at time-dependent pressure data, gives you an output in decibels. Literally, how loud is it going to be? So if you want to design something like a suppressor, maybe a nice Flowmaster exhaust system, no need to go cut metal to figure out how loud that design is going to be. Flow simulation is a pretty complex thing. It's computational fluid dynamics, but SOLIDWORKS puts this at the fingertips of any designer. You already know how to use this type of interface. So now I've looked at something for design. I've looked at something for strength of a finished product, but what about using simulation just for manufacturing defects? SOLIDWORKS Plastics simulates the injection molding process, so you can predict cycle times and how to reduce them. You can even go so far as looking at, is a part going to warp when it comes out of the mold? This gives you some of the most advancing meshing capabilities from shells, solids, tetrahedrals, hexahedrals, but they're easy to manipulate in this redesigned meshing user interface. Even if you're working with a family mold layout, you can use mesh groups. It's very simple to control. Clamp forces have been improved as well. You can choose direction, and if you want to omit something like a slide area, you can do that. So you get more accurate force calculations, help you better select the size of the machine you're going to need to actually make your part. When looking at results, you can look at them in any directions. If you're wondering about accuracy, something like a short shot is predicted with the glass transition temperature of the material. Plastics will look at the frontal flow area, and if the temperature ever drops below that glass transition temperature, a short shot is going to be predicted. So simulation can really be used in any part of the engineering design cycle, from the very beginning to when something's out there on the floor to manufacturing in between. But whichever product you use, you're going to have to share this stuff with other people. All of these results are completely supported by eDrawings. eDrawings is a free viewer. You can use the sim results there to share with others. You can look at your top level assembly because it's another lightweight display data type program. And if you're back over in SOLIDWORKS, eDrawings should look just like this. Take, for instance, these batteries where I'm using decals. In 2018, if you're using something like decals, appearances, scene data, you can actually save that with the file you're looking at. That means when you open something up in eDrawings, it ought to look exactly like it does in SOLIDWORKS. But if you haven't used eDrawings, or you're sending it to someone else who doesn't have SOLIDWORKS, you'll notice a bit of an interface adjustment. Some of the buttons are larger, easier to use. If somebody's left markup, notice this exclamation point. So I'm not going to miss that there was a comment left when I'm going back and forth with someone about a design. Larger buttons over the top give you save and open. And if you hit plus to add a new tab, it's also an open dialog. I'm going to open up the whole chassis of this RV. Notice that new progress indicator telling me how long I have to wait. And I didn't have to wait very long at all. Get into your settings when you're in eDrawings. Make sure you've got the graphics boost set to fastest speed. There's some new graphics pipelines that really speed things up. Now, if you are a SOLIDWORKS user, just manipulate things with the tools you already know how to use. If you want to do something like move a component, you can use units like feet and inches. Select something to explode, you get the same triad and arrows that you use on the SOLIDWORKS side. It's so much easier to explain to someone the idea of a design or what's going on in 3D like this instead of having to, read over a 2D print. And that's why we're seeing really so much uptake in model-based definition. This is the ability to do all of your manufacturing detail in 3D. And the way this works is it captures 3D views. So these views remember which annotations you want to show and what orientation. Literally all of the section or detail information you would have had on a traditional print, including different configurations. So if you set something like this up, you want to export it and share it with others, an easy way would be publish this straight to eDrawings. eDrawings will support all the different configurations, plus I can attach step files in all the different popular formats like Step 242. And for those of you who are wondering, yes, you can password protect this, so you can decide who exactly is going to be able to actually look at the step file and who isn't. So what does this look like in eDrawings? Well, it looks just like it does over in SOLIDWORKS. You get 3D views down in the bottom, and when you select one, it brings you the exact orientation. Plus, you're in 3D. You get cross-highlighting and manipulation, and I get the name of the configuration I'm looking at right at the bottom. How about those attachments? Well, those are right here too. I could select one of these attachments. Let's say I have the password. I could strip it out of the file, extract it, save it on its own, remove it just to reduce file size, or I could view this attachment right here. You may have missed just how powerful this is. I just opened a Step 242 file inside of eDrawings. It's because eDrawings, this little free viewer, opens up more file types than ever before, including all these intermediate types like IGES or STL or STEP. Maybe you got a computer in the shop you don't want to put SOLIDWORKS on at all, but you just need a viewer. eDrawings can do it. And if eDrawings can do it, you can bet that SOLIDWORKS can do it. I'm going to go ahead and open up a step file over here. This was actually a file that was made in CATIA. It's 242 step. And notice this new box that says include PMI. PMI is that product manufacturing information. Some people call it paperless manufacturing information. It's this MBD or model-based definition stuff. Even though this is a step file and it's imported, I still get all that information. In fact, every major CAD program these days has a way to do this manufacturing information in the 3D environment. And it's not just for parts. This stuff actually works on assemblies as well. You can just reuse the feature dimensions you've already made. You could make new smart dimensions, or you could automate this process a bit using DIM Expert, which is what I've done. And I'll show you this a little bit. I'm going to open up a part, kind of a common part here. I could use the auto dimension scheme and just let it provide all the dimensions for me. I could go reuse any tolerance scheme I've already set up on feature dimensions. Notice I have 3 holes here with equal importance. It's okay, I'm going to put a datum feature on there, just a DIM Expert datum feature. No problem placing that anywhere I want. Now, honestly, I've set up some 3D views ahead of time. I did this because I want to illustrate to you that anything you do on traditional prints, you can do here in the 3D environment. One thing that would come to mind immediately is what about that title block information? If you get something like a standard note, just drag it in. It becomes what's called a 3D note. So just place it on the screen where you want it to go. This is the orientation other people will see. And I'm going to edit this and add a general profile tolerance for any surface that's not specified. Easy as that. Now, the reason I did that is because this is parametrically linked. If I come in and I decide I want to start changing my general profile tolerance, maybe I want to tighten it up from 0.5 to 0.2, make things a little tighter. That immediately updates in my note, just like any custom property would that you have mapped into a traditional drawing. And you can reuse all this work. I did some work here in the part. I'm really just showing a lot of these part level DIM Expert annotations here at the assembly level. Even if you have parts that match up together, you could speed this up. For instance, I've got a hole pattern that goes through 2 parts here. I created these by using the auto pair tolerance, just taking the tolerance scheme from one part and sharing it with the adjacent one. So I didn't even have to dimension the hole pattern twice on 2 different parts. Now, at the end of the day, we want to lock down manufacturing information, right? 2018 comes with a huge template database of 3D PDFs. I'll show you what this looks like. It looks the same for parts and assemblies. This is a regular PDF format. You don't need anything special to show. This is the free Adobe viewer saving as a 3D PDF. Notice my note was kicked to a notes area, just like a title block, and it's got my information in here. Down at the bottom, I've got those saved 3D views. They give me the right orientation and annotations, plus a little bit of 3D manipulation. And notice this arrow right here. This lets me play these different views, just like you can scroll through views in eDrawings. The cool thing about this is I've made several configurations and configuration-specific properties. Notice how they're changing with each view. So if I don't want to even have a multi-sheet drawing, I can do all of this, stay on my computer, my iPad, anything that looks at PDFs, and I only need this one page to see all the information. You know, with all of these abilities, it's pretty much not surprising that almost nobody makes 2D prints anymore. It's basically obsolete. I'm just kidding. I know I can't see your faces. I know a few people scoffing. Of course, everybody's still making 2D prints. You know, these different workflows, they're not made to replace one another. The point is they all work together. Let's say I do want to make a traditional print, but I've already done some of that work. I'm just going to import those 3D view annotations I've already set up. I can just drag in a view, and I don't have to go do any separate work, and I get a standard traditional print. It only takes me about a few seconds here. If you're doing something twice in SOLIDWORKS, give us a call. Now that looks pretty good. It was fast, but all the traditional drawing tools, of course, they're getting some more power as well. How about in the last year? Has anybody used that advanced hole wizard? I hope you have. This is that hole wizard that lets us do multi-stepped holes. You can do a million counter bores at either end of the hole, really make something complicated in one feature. And when you get over to a drawing, you can test somebody on how well they can read a call out, build them a super long hole call out. You still get complete control over how that call out looks. How about cross-hatching? That's been around forever. I want it to have a specific look and density. I can just assign that to a layer. So anytime I use a crosshatch, it's going to come out just like I want it. Or how about this? Dimensions with trailing zeros on them. They may look different when I've got them in tolerances, dimensions, custom properties. I can specify that, let's say I show trailing zeros on my dimension, but I remove them from my tolerances. I'll leave them alone in properties. And I can get a drawing that looks exactly how I want it to, matches my company standard. I'm going to go a little further into cross-hatching. Here I've got a section view set up. Got a detail view on a section view. I'm going to make a broken out section view on this section view because I heard you guys like section views. So what I did was I sketched a rectangle ahead of time. I left it here. And I'm going to make a broken out section, just cut into this, mainly to show you this randomized scale checkbox. This is the scale of the crosshatch I'm talking about. So when I hit OK here, I'll just cut in 10 millimeters deep. Watch the cross-hatching change. It's all the same right now, even though I have different parts. Now the scale is randomized. Really makes it more clear, as long as you're not using those cross-hatch layers, need something specific. Really, a lot of these views, they work together. Even if you got something like an alternate position view, you want to add something on top of that view, like a broken out section view, just go for it. You can really chain these views together nowadays. And this is a pretty big assembly drawing. So I'm going to need balloons. I'm going to need a bill of materials. This thing is looking pretty good. Of course, I didn't type this bill of materials. These are all custom properties which are mapped from the individual parts. And it looks like I've got some engineers typing in lowercase, some in capital letters. Anytime you're working with a table in SOLIDWORKS, one button over the top will capitalize all the text. Sometimes it's really small stuff like that that actually saves me the biggest headache. And I've got a drawing that looks pretty good right now, probably ready to go through my SOLIDWORKS design checker. So maybe I'm done. You know, I've made some parts here, I've optimized them, I've done simulation on them, and now I'm ready to go. I made a drawing, made a print. It's really one more step. I need to make first article inspection document. SOLIDWORKS inspection takes 90% of the time for this, and I could use it right here on a drawing, but of course, if it works on stuff like drawings, it also works on this 3D stuff. Now this uses any dimensions that I've put in, my feature dimensions, my dim expert. I'm just going to start a new SOLIDWORKS inspection project. I'll just pick a default template. And my templates I could set to automatically map custom properties, or I could just fill them in like a part name. I could choose from a predefined drop-down list. Maybe different vendors are going to have different sampling rates. And then I'll decide what things I want SOLIDWORKS inspection to automatically pull from my part. When I hit the green check, inspection does all the work for me. It starts moving around my part, my different configurations, my different views, and building me a bill of characteristics. This is something I can review. So I can move down the list and say, okay, what's going on with this GD&T? I can see the cross highlighting. I can change the tolerance here if I want to. Once I'm happy with it, I'm just going to export this to Excel. So I'll have those FAI documents. Some of the built-in templates are here, like PPAP. I'm going to use an AS9102 template, and I'll just go ahead and kick this out and save it in real time so you can see just about how long it takes. It's a very fast process. This is going to open up Excel for me. Here's the FAI document that I just made. And of course, because you're in Excel, you get stuff like conditional formatting. If you had some digital calipers or a CMM, you can go through the entire inspection process without ever typing or writing a number down, never fat fingering anything, and saving all that manual time of writing and highlighting the stuff. But of course, a lot of the inspection stuff is not done maybe at the same desk as the SOLIDWORKS engineer. It might be out there on the shop floor. So inspection does have a standalone program for this. I'm going to go ahead and start up a new project here. Again, I'll just pick kind of a default template, and I'll go grab something to work with. Now, this could just be a picture. It could just be a PDF. I'm going to grab a DWG. If it was a PDF or a TIFF or some picture, this has an optical recognition technology in it, just like the way you deposit a check and your bank reads the numbers. So it can just read numbers and tolerances right off a sheet. But I do have a DWG. It's got selectable text. So I'm going to use Smart Extract and just click on dimensions I want to capture, maybe tolerances I want to capture. Notice they go straight to a table. It can read the plus minus tolerances. Even in my template here, I've set up dimensions to be measured with a CMM and general tolerances to be done with an articulated arm with a probe. I don't have to worry about clicking things a second time. I won't get duplicates, which means you can just box select everything you want. It's that quick to make an FAI document. Now, if you do want to manipulate these a little bit closer, I'm going to zoom in on a few. Anything you click on is going to pull up the characteristics on the left for it. It's going to cross highlight in the tree. Maybe I want to say that this is a critical dimension. You'll notice the balloon change. I could alter its tolerances or just drag and drop if you want to renumber this table. It's a SOLIDWORKS product, guys, so it's just going to work the way you think it does. When in doubt, right click, try it out. Sometimes you want different numbering schemes for these, though, like on a detail view or a second page. I just started at number 1, but I'm going to use a separate sequence here, and I'm going to start the rest of these at 100 or wherever I was last time I used that sequence, and I'll just box select the rest of the items I want included. So when I'm done with this, I need to put out an Excel sheet probably, maybe save this as a PDF so somebody can see where the actual balloons are, put some char zones on it if I want. I'm just going to go straight to Excel. And down at the bottom, I have the ability to include snapshots. Maybe I need some more information about one of these detail views. I'm going to take a snapshot of that, and I'm going to include my overall model and my snapshot and just export this thing. It's basically the same as when you're over in SOLIDWORKS. Save your project. I mean, look at that thing going to work for me, doing everything without me touching anything at all. And then it opens up Excel. Here's the screenshot I just took, the overall model. I don't even need a PDF to go along with this, plus all of my inspection forms. That standalone program you can hook straight up to a CMM as well. So you could even do all of your results inside of this table. But why am I showing a 2D product? Everything I've just been harping on was all about 3D. So I'm going to open up something else. A standard template, I'm going to open up a ProE file, a Creo file. Because this doesn't just work with SOLIDWORKS files, it works with all sorts of files. This one has some of that PMI information in it. It can be made in a number of products these days. And I'd like to do some more smart extraction. Same way I did before, I just box select everything. So this works on 2D and 3D. The next real question that comes to my mind is what happens when I get to Rev B. I'm going to import a revision CAD file here, and basically I'm going to go to Rev B. So I'll save my project. In other programs like ProE, they have to make a whole bunch of different parts for Rev. So I've got my .2 PRT here, and I'm going to open that up, and I can do a manual revision. Of course, I'm going to do an automatic revision, and let SOLIDWORKS show me color coding in my tree plus in the graphics area what's added, changed, or removed. I can choose what to keep. I'll just keep everything here. And then once again, I can go through this process of exporting to Excel. I'll grab a template. I can include screenshots if I wanted to. And you've seen just in a couple seconds here, I made a first article inspection document, following the AS9102 template format for every dimension and tolerance that's in this part, and I went from Rev A to Rev B. Now that's a lot of time savings. If you've ever been through FAI the quality way, talk to your QA guys about this, ask them how long it takes. It's pretty substantial. And now I've got everything I need. Now I'm done with this project. I've gone all the way down to maybe talking about QA and being the shop floor and not the SOLIDWORKS designer. But actually, I don't want to be completely done until I'm holding it in my hand. So I'm going to show you my third favorite enhancement to SOLIDWORKS 2018, and that's the addition of SOLIDWORKS CAM. And everybody on the webinar with SOLIDWORKS 2018 is going to get SOLIDWORKS CAM. It does work slightly different. It's not a perpetual license, so you need to have an active subscription service for this to work, but there's no charge. It's right in there. It's another tool in the toolbox. This is what you call a 2.5-axis CAM program. It's based on the CAMWorks technology, so it works really nice for routing out pockets, for more simple parts. If you get into something more complicated, something that needs a third axis, let us know. We'd love to help you find a solution. MasterCam is obviously very capable for something like this, but if you're a subscription customer, just consider it another tool in the toolbox. If you've already installed 2018, it was just a week or two ago when this fully came out, so modify your install, make sure CAM is on there. Otherwise, when you first activate SOLIDWORKS 2018 is where you're going to find CAM. Now, I'll show you a little bit of what this looks like inside of SOLIDWORKS. I have a video, and I know they've been a little blocky, but I'll pause it a few times. What I want you to see is that this is in the same interface that you already know how to use. This uses a automatic feature recognition technology, plus it uses some manufacturing best processes and some rules that you've already set up to determine feeds, speeds, step over sizes, all that kind of stuff. When you get done, you get a tree. You can manipulate, add more things to it if you need to. You get to work directly with your CAD file and your different configurations. So you shouldn't have to make any reference geometry like additional sketches to add what you want. Now, what's cooler than this is when you're completely done with this, you can simulate this inside of SOLIDWORKS. That toolpath simulation, you're not even setting this to machine yet. You know, if you're going to drill any extra holes or, you know, see what your surface finishes are going to be like. And as you're probably guessing, this is parametric. So if you make a change to something, you just rebuild and get all these toolpaths regenerated. This is a perfect thing for somebody who has maybe an at-home router. It works on parts and assemblies. It even works on turn parts. So you got a lathe and a router you're trying to control. Really awesome benefit of being a subscription customer at 18. You do need to stay on subscription for it to work. I think that was a question from Jerry. But that's about it. It's just another tool in the toolbox. Now you could take it a little further. There is some tolerance-based machining that works in here as well. So if you're adding those DIM experts, you're putting in additional tolerances using tight GD&T. In addition to your rules, your manufacturing best practices, in addition to your automatic feature recognition, this will look at those tolerancing setup and come up with a scheme and order of operations for machining. So depending on where your datums are, depending how fast or how tight you want your surface finishing to be, you might need smaller surface finish cuts. You might need to start at a different 0-0. And of course, if you go back, you change the fit of a hole or you change your tolerancing, this is going to rebuild and be tighter than it was before. This is something that can take a really long time to make G-code for something that's a really high tolerance part. This takes it down to really a couple minutes, and of course it is parametric. So now I'm pretty out there. Now I'm talking about actually cutting out on the machine shop floor. It's pretty amazing we get this ability. I'd like to step back for just a second and put you in the mind of a customer. Somebody who's not down there on the floor, not an engineer, but just wants to get good designs and be excited about a product they're buying from you. Take, for instance, this RV, right? This RV is heavily customizable. It's going to have different paint jobs. My wife's going to want different materials in the kitchen of it. I'm going to want a different diesel engine so I can tow my boat behind it. So there's a lot of different configurations you could come up with. So what we need is some kind of configuration tool. And that's where DriveWorks comes into play. DriveWorks is something that can run in a website. It could run on an iPad, and it lets you manipulate parts, turn them around. I hope you guys are seeing this video all right. Let me know in the questions if you're not. And interact with pre-set up configurations. That means they're not suggesting new ideas, but they're saying, let's try steel, let's try aluminum mag wheels, see the weight change, see the price change, get excited about the product instead of coming to you and saying, what about this? What about that? When this is done, it can also put out stuff like bill of materials or quotes or any of the documentation you need, like a cover letter. It goes so far as that if somebody puts in a phone number, maybe some credit card information, this can automatically start generating the full quote process, and you can kick it off and make any other documents needed. That includes your SOLIDWORKS parts, your assemblies, drawings, photo renderings, e-drawings files. This all gets pre-configured and automated. Now look at this thing just cranking away right now. It's crazy. I don't have to touch anything and get the product done. You could go so far as to set up a web server for this, not even be involved. The quotation process is automatic. They could even put in a buy it now, the work order gets generated. That's pretty high level to talk about letting everything go to the customer's hands from that far, from beginning to end. But it's very granular. You know, if you haven't heard of DriveWorks before, DriveWorks Express is in every seat of SOLIDWORks. It's just on the Evaluate tab, try it out. DriveWorks Solo has a free 30-day trial. And then DriveWorks Pro will go to that top level where you can even set up that server. You may have seen this type of technology if you've been out there before, maybe customize a sneaker on the Nike website. That's the type of thing we're talking about. MLC has several experts here to help you set this type of thing up. If you're interested in the technology, let us know. Let's talk about something that you already have, just like DriveWorks Express, that is also for customer experience, and that's SOLIDWORKS Visualize. SOLIDWORKS Visualize is a hyper-realistic photo rendering program that's in every SOLIDWORKS Professional and Premium seat. What I've opened up right now is that same coffee mug holder that Marcus showed us how to make, and I'm just going to export this and kick it over to Visualize, because Visualize is linked to my SOLIDWORKS files. So if I make a change over there, I need to update some different photo outputs, I can do it here. Now I'm going to start in a preview mode. If you haven't seen Visualize before, you ought to just install it. If you have SOLIDWORKS Pro or Premium, you can get Visualize Standard. It has really large buttons, easy to use on a touchscreen, no long scroll menus, plus a heads-up panel over the top. So you can do things like go through your standard views. It's pretty much tools you already know how to use. Isometric, you can lock your view focus. You could even do a fit to screen. And since this comes from SOLIDWORKS, if you've saved any views before, all of your saved views are available as well. Let's modify this a little bit. I want to add some looks to it. It's got whatever appearances or materials came from SOLIDWORKS, but there's a huge built-in library of appearances as well as a cloud to get even more, plus all of my SOLIDWORKS appearances like paint. Let's use a high gloss paint, and I'll just drag and drop the appearance where I want it to go. It's that simple. There's not much of a learning curve. The tutorials for it are free. They're out there. Just use the same mouse stuff you know in SOLIDWORKS. Drag and drop. If you want to add something, when in doubt, right click. I'm going to add a light, and this is actually a Visualize Professional item here. And what I like about this is I get to pick the target where I want the light to go. I'm going to click, I want a light to shine right here on this coffee mug. And you can see the light got added. Let me zoom out and see what that looks like. It looks like a big square. All right, let's adjust this light a little bit. What I'm going to do is, I think I'm going to keep it visible, and maybe we're in a photo studio, change it to a disc. Or really, we're inside of an RV, which would have fluorescent lighting, so let's go with a tube. I'll make it a little bit smaller, maybe adjust its length. I can change its position and see how the shadows update, but I want more than shadows. Zoom in on this and get it, oriented nicely on my screen, like I'm going to make an output. Notice I'm in a preview mode. I'm just running this on my little Dell 6700 laptop. I'm going to hit the tilde key to turn on my GPU rendering passes. This can do GPU or CPU rendering. Plus, you could mix this up. You could use Visualize Boost, literally take over all of your coworkers' machines, have yourself a little render farm. You can see the nice shadow, the nice lighting on here. If I zoom in or rotate, I get pretty much an immediate pixelation here. It starts to res up. So I can adjust, get the shine I want, and then set these up in a render queue to start publishing these images. If you're interested in something like this, especially with the lighting, you're probably interested in Visualize Professional because you can get even more immersive. Maybe you want your customers to be really inside of your assembly. You can do this with a spherical camera. Save a spot so they can get to a website or a published output, literally drag their mouse around like they're standing inside of your assembly. That's pretty cool. Or take it even further because this supports stereoscopic imaging. So if you have maybe a Google Cardboard, some kind of VR site, not only are they standing inside, but they're getting the full representation of virtual reality, and it's just your SOLIDWORKS assembly. These really are photorealistic outputs. A lot of outputs here you cannot tell started in SOLIDWORKS. Here's a nice spherical camera with a solar study going on. It's amazing that these start as CAD files. PhotoView 360 still has its place, but Visualize is awesome, and it's there in SOLIDWORKS Pro. It's there in SOLIDWORKS Premium. Plus, you can take that up to Visualize Pro, even use Visualize Boost.